Hello everyone, welcome to my YouTube channel. Myself Kailash Kumar 1VE21CS074. Let's start with a new topic, data efficient performance modeling for configurable big data framework by reducing information overlap between the training example. Let's start with the first slide. Introduction. Problem statement, goal, constraint, context and key challenge. Problem statement. Performance modeling for comparable big data framework is challenging due to the large number of configuration parameters. Goal: build data efficient performance model by reducing the amount of training data needed through minimizing information overlap between training examples. Context: big data frameworks such as Apache Spark and Hadoop offers many configuration parameters, making performance tuning complex. Key challenges: gathering sufficient training data for machine learning modeling can be expensive and time consuming. Motivation: high dimensionality framework like Hadoop and the Spark offers many tuple parameter. Current approach requires large, often retunable dataset for accurate performance modeling. Goal: reduce the training dataset while maintaining prediction accuracy by focusing on the unique information example. Redundant data problem in traditional performance modeling. Many configuration setting results in similar performance outcome. This redundancy leads to inefficiency while building modeling models as new training examples add little value. Impact on real world application in environment where tuning is for performing cloud service distribution database on interface modeling happers quick decision making and the resource allocations. Challenges in exiting approach: high redundancies, data collection cost in inefficient model. Traditional method generate redundant data which make the modeling process inefficient. Gathering performance data across numerous configurations is expensive in both time and resource. Inefficient model overlapping example lead to less efficient learning and the lower model performance. Propo- pro- Proposed approach: key idea, reduce overlap by strategically selecting training samples that provide novel information and diversity aware and sampling. Introduce techniques that part- prioritize selecting driver training example. Expected outcome: improve data efficient with fewer examples required for training. Core innovations: minimizing the number of trainings example which maximum the information gained from each. Information theory basic: the strategy leverage principle for information theory to ensure that each example selected had sufficient new information to the model, reducing overlapping between examples. Model scalability: the reduced dataset improve the model scalability for large-scale system, particularly for application in cloud-based system, edge computing, and the high-performance cluster. Methodology: identify configuration parametric, define the parametric space for big data framework, and diversity-aware sampling, user clustering, active learning, and the uncertainty based method to choose information example. Model training: build a performance prediction model using machine learning with the reduced dataset. Model evaluation: access the model accuracy, efficient, and the ability to generalize the unseen configuration. Diversity aware sampling techniques, clustering based sampling, group similar configurations, and the simple from residue culturing. Active learning: select configurations that are predict to maximum the model learning potential. Uncertainty based sampling: focus on example with the high prediction uncertainty to improve model accuracy. Residue sampling for robustness, ensuring diversity in the selected example. Enhance model um, robustness by covering edge cases and uncommon configuration. Entropy based metrics: the method employ entropy calculation to precise training sample that increase uncertainty reductions, making the model learn more efficient. Uncertainty sampling samples with high uncertainty in their performance predictions are selected to improve the model accuracy. Evaluation matrix prediction accuracy, how accurately the model predicts performance metrics like runtime, data efficiency, the reduce in the number of training example need, generalizing model ability to predict unseen configuration efficient results. The proposed model achieves significant accuracy with fewer examples, reducing the data size by up to the X% efficiency gain. Model built using the proposed approach shows significant reduction in the training data requirement while achieving similar or better accuracy than traditional method. Cross verification validation result by testing the model against multiple datasets. The evolution demonstrates a strong generalizing capability, especially in the unseen configurations. Data reducing rate experiment indicates a potential reduction for training data by 30 to 50% with non-losses in the model performance. Conclusion and the future work. Conclusion: a data deficiently performance modeling approach that reduces the number of the training example while maintaining accuracy. Diversity aware sampling, ensuring the model learning efficient from the few more in informative example. Future work: extend the approach to the other big data framework. Explore future improvement in sampling techniques like deep learning based diversity measurement. Thank you. Signing off.